Good afternoon. First of all, I want to say this presentation is a collaboration with two great teachers. One of them, my chemistry teacher, Catalina Carmona, who has been helping me to understand the anatomy and physiology of the neurotransmitters, and so on, the pros and cons of the medicines we have nowadays to help this type of patients. Also, my teacher of English, Yadira Hernandez, who has been helping me with the presentation, grammar, vocabulary in English, and also to understand the anatomy of the brain, even in a real way, which you can see on a dissection of a cow's brain. Also, I want to say thank you to my partner, Eric Islas. To begin with, I will start explaining the anatomy of the brain because personally I think we can talk about a pathology without knowing the anatomy of the organ we are talking about. Then, to be more specific, the anatomy of the neurons and its physiology, of course, the neurotransmitters. Then the pathology of Alzheimer itself and the connection between the anatomy of the brain and the anatomy and physiology of the neurotransmitters and neurons. Finally, some future advances we will see. Here you can see a healthy human brain. For its study, the brain is divided in different lobes, which we can see in different colors. Here is the frontal lobe, occipital lobe, parietal lobe, and the temporal lobe. Also, for its study, the brain is divided in two hemispheres, the right hemisphere and the left hemisphere. Many people think that the right hemisphere is only for arts and the left hemisphere for the more logical part. However, this is a misunderstood because the left and the right work together in order to have capacities and abilities function. Each lobe of the brain has a specific and different function. For example, here we have the function of skill movements, the visual function, reading, and movements activation. So on Alzheimer, we have changes in judgment, here, in reflection, emotional reaction, body reaction, and adverse movements. So you can see that the most damaged part of the brain is the frontal lobe. But why does this happen? Well, to understand that, we need the anatomy of the neurons. Well, the neurons, first of all, are the basic working unit of the brain. They are specialized cells that transmit information. They are approximately 1 billion, and this is really important. At the age of 20, you start losing a gram of brain mass per year. So the anatomy of the brain consists of dendrites, nucleus because it's a cell. Of course, we have an axon and an axon terminal. This axon terminal will help the cell to transmit information to another cell. So how does the neurons work? Well, this is a potential action. As I have told you before, the terminal axon connects with other terminal axon of other neurons. So here it happens this process. Potassium go outside and inside we have sodium. The sodium and the potassium have a negative and a positive charge, which will help us to have a potential propagation. And this way, the neuron can transmit the information. It's like a superpower, don't you think so? Now let's talk about the Alzheimer disease. The Alzheimer disease is a brain disorder. It is irreversible until nowadays, and it's progressive. What does that mean? Many of the pathologies of the brain have this problem. It's progressive. We know we have a type of pathology when this is really advanced. As here it says, it slowly destroys memory and thinking skills. And well, it is not like a rule, but in most of the cases, this pathology damage the older people. However, there are cases of people who has 30 years old. Stages of Alzheimer. We have three main stages of Alzheimer: initial, intermediate, and terminal. Each one has its peculiarity. However, Something that is really noticed in the three of them is the difference in the shape of the brain. For example, the healthy brain is bigger than the mild Alzheimer. This is because there is neuronal death. And which type of neuronal death? Well, we have two major types of neuronal death, apoptosis and necrosis. Apoptosis happens when the neuron doesn't have synapses enough to stay, so it's not really used. And what will happen? Well, the neuron will start dying. We have the neuronal death. This type of death consists or happens because the brain or the neurons need a more efficient organization of the system, so it is a natural process. That is why we said before that at the age of 20 years, the neuron start dying. Which are the causes of the neuronal death? Well, we have also two types of causes, genetic ones and for expression. Genetic ones, for example, changes in the structure of neuronal receptors, which basically are proteins in the neurons. An inadequate production of neurotransmitters. We can have more neurotransmitters, less neurotransmitters, or don't have it. Specific sequences of microRNA, receptors and microRNAs. Here we can see a type of receptor which is in the neurons. Then we have a microRNA, let's 7b. But what happens when these two get together? Well, something like this. However, the junction of these two molecules will cause something known as inflammation, and a constant inflammation will cause apoptosis. Yes, apoptosis. So on, Alzheimer disease. This is one of the causes that is being studied nowadays. And it takes us to the other cause, an overexpression of certain receptors which interact with some neurotransmitters, which happened in the example I have told you before. The neurotransmitters are molecules that help the neuron to communicate. For example, it's time to sleep. However, if the binding site, which is a protein, or the receptor, have a molecule change, the neurotransmitter won't bind together with the receptor, so on there would be a misunderstood in the message of the neuron. Make activities like reading, learn a musical instrument, learn a language, eat healthy, and work out. Thank you, dear audience and teachers. I hope you enjoy it as much as I have. Thank you. See you later.